You're going to have like models that are smarter than you in the future, and you want to check their answers. You can get two experts to have an argument, and then you can have a non-expert check that argument. That's the premise of debate. There's lots of people who work on AI safety because they're very worried about the doom. I work on AI safety because I think it's the most interesting intellectual problem of our generation. Getting things smarter than you to do what you want is like a problem as old as parenting. Having been doing ML since like 2015, it's hard to imagine a world where the progress doesn't keep happening. There's lots of incentives for us to try keep making these models smarter. And I don't think we've hit any natural limit in that.
So what are you doing this week? And finish telling us about the paper.
Awesome. So this week I'm at ICML Vienna to present what has now received a Best Paper Award, which is debating with more persuasive LLMs leads to more truthful answers. It's hopefully the start of a really good set of scalable oversight work in the alignment track. And I think this is the first Best Paper Award that's gone to like an alignment paper. But it's like hard to verify this. So I've asked a couple of people who've been in alignment much longer than me. This seems to be the case. In particular, I think the introduction is a great case for why you should worry about systems being smarter than us and not being able to supervise them. And in particular, it provides an empirical operationalization of like things are smarter than you, how are we going to check them? Based on some work by Ajay Kotra and Sam Bowman. So I think in particular scientists or like researchers will really like this because it's like, how do we operationalize this like problem of a thing being smarter than you? We also show that like this works well with humans as well.
I know that you've got, a personal interest in alignment, and maybe we'll get to that afterwards. Yeah. But I did want to just use a bit of time on your paper from this is at ICML, right? So
yeah,
debating with more persuasive LLMs leads to more truthful answers.
Yep.
What's the elevator pitch?
So the elevator pitch is you're going to have like models that are smarter than you in the future, and you want to check their answers. So you can think of this equivalent of like something that stresses me out a lot is if I go to see a dentist and they tell me I need like 2 cavities, like fillings for cavities, I just have to like take them at like face value that they know what they're doing because I have someone here who's like a domain expert and it's very hard for me to check their answer. So what do I do if I like don't trust my sus dentist? I instead go and get like a second opinion from a different dentist, right? Like I take like whatever the x-rays are of my teeth and I take it to them and I ask them for their opinion. They will say something else. And then like normally what happens is I take their feedback and bring it back to dentist number 1. And there's like this like constant flow of arguments between them. And then I make an informed decision based on it. That's the premise of debate, which is you can get two experts to have an argument and then you can have a non-expert check that argument. And it's kind of like, it's why we use debate in the public spaces that we do. The reason that debate doesn't work in public spaces, which I think is like obvious, is that like most of the time, like the 2 debaters aren't equally matched. And like the fun thing about doing alignment work is that like I can literally take a copy of a model, so I can like make sure the capabilities are adjusted for. So there's kind of like 2 things happening here. One is like this adversarial expert versus expert thing, which is like a fair game. And then the second thing is that it's easier to check answers to a debate than it is to make arguments in a debate.
A few things on that then. So yeah, there's this term, the wisdom of crowds, which is that if you're doing epistemic foraging, diversity is good, but maybe not always, because you might have lots of people in the crowd who don't know what they're talking about, or you might have people who do know what they're talking about, like, Jan LeCun and Hinton, and they vehemently disagree and they don't really converge. So sketch it out for me.
So first of all, like taking multiple votes in LLM debates does help. Maybe it's like empirical piece of evidence cool. For the moment. Second, like maybe meta point on like the whole like popularism or like, just like wisdom of the crowds is normally wrong thing is like, I think like the failing of the wisdom of the crowd thing is something like it's very hard to keep a crowd fully informed on a thing, or it's like hard to make them attend to a debate as fully as you'd like them to. So I'm like worried a bit less about that in this setting, or like the wisdom of the crowd kind of like worry is maybe more of like, you have like lots of judges and very few debaters. And the setup that we're envisioning using this stuff is not really that.
Yeah, so in this setup, and then this is really interesting, right? Because people talk about language models hallucinating.
Yeah.
And I guess what's happening is there's this kind of traversal space. Yep. So you can traverse many different directions and you get slightly different results. Mm-hmm. And what you've come upon is there is a non-interactive kind of adversarial way of probing that space, which closes the gap, getting closer to epistemic truth, whatever that means.
Yeah, I mean, I don't think we'll use debate for hallucinations, so to speak.
Okay.
Like, I think like hallucinations is just like a quirk of like this size model at the moment, and like that's less of the problem. I think maybe going back a couple of steps.
Yeah.
This debate thing is maybe useful for two reasons. First of all, like maybe you have models and you don't trust them, and you want to have an argument over one of their outputs. In which case, you could either like model suggests a solution. It suggests a plan for a new nuclear reactor, and you or I, not knowing that much nuclear physics, are like, well, it kind of looks like a bomb, kind of looks like a reactor. I can't tell the difference. You know, they look the same to me. What we can then do is we can get like a model that's maybe smarter than us, or we can get that model itself to then we can take a clone, steer it so it has to advocate for this answer, advocate against this answer, and then check it. And then here we get to leverage the knowledge without having to worry about if it was being truthful or not.
Very cool.
The other way it can be used is just like a training signal instead for like RLHF.
Can you sketch out an example?
For the training example? Or
like an adversarial setup. So let's say we've got a problem that we need to know. And
okay, cool. So you train your latest big large language model, and you're skeptical because all these AI safety researchers for a long time been like, hey, you shouldn't trust this thing, and you're like, well, I don't really know. But you ask it to like propose an alignment plan because the Superalignment team at OpenAI is like, we're going to automate alignment because we can't solve it ourselves. And you're like, well, this kind of looks a bit sus. How do I check this, right? And then what you do is you take that copy of the model or another smart model that maybe is like. Maybe like say you have like GPT-8, and GPT-8 you really don't know if it's good. You've done your RLHF training, but like you're just scared to like touch the box or let it talk to the internet. But you maybe trust GPT-7 a bit more, but less so. You can use GPT-7 to do the debates and hope GPT-7 then like. The thing that's nice about debates is they resolve to cruxes. So like you and I, if we were to have a disagreement, would hopefully like reduce the search space or solution space or the critique space to like looking at we both disagree about this fundamental fact about this thing. And like that fundamental fact is normally much easier for an external party to check than the entire thing. So like, I don't know, some debates about abortion like normally reduce down to like, when do you think like life begins, right? And like working out when life begins is an incredibly hard task, but it's much smaller than asking like, is abortion right or wrong as a thing. So I think that's maybe the example that I'd give.
Yeah, interesting. I wonder how much kind of prior knowledge and prompting needs to go into this, because in my experience, language models are really good when you give them a lot of structure. You do chain of thought and so on.
Yeah.
So let's say in this setup, wouldn't it be great if the human says, here's a problem, and then this whole adversarial setup spins up non-interactively with minimal priors, minimal prompting? Is that what you envision?
No, so I really envision we take two copies of the model and we like hard code fuzz one to think that it's arguing for this and hard code fuzz the other one to think that it's arguing against it.
Yeah.
Yes, there's like two ways to look at this. One of them is like you're doing this thing what I'm suggesting now, where I'm assuming the thing might be deceptive or misaligned or whatever you want to call that. And in that setting, you really want to do this because then you're really like, you know that you correctly incentivize the models to expose all the critiques. The other setting is we just don't know what the answer is. And this is like the traditional scalable oversight setting, in which case you can imagine that a model might already internalize this dialogue and do it itself. And maybe you can just ask the model there for the answer. But this is also a very good way of having interpretable results. Or like if you want to annotate something, then using a debate, looking at a debate transcript is like really helpful. We did it with humans. And in general, when you're arguing both sides, humans are better at like answering the question, like reading debate first and then having to answer the question.
Yeah. Is the assumption here that we've got a really smart language model, a very knowledgeable language model, and it kind of knows all of the different aspects of the debate. So it's kind of teasing it out and doing it in an adversarial pattern, as opposed to having to kind of sample more information from the world we live in order to resolve uncertainty.
So it does two things. One thing is it like elicits a behavior we want from the model, which is not just a correct answer, but it's an explainable and persuasive answer. So if the judge is like a 12-year-old or like with a 12-year-old's level of maths knowledge, then like if you want to answer like an A-level physics question, you're going to have to like really break it down and only use like very basic algebra, this kind of stuff.
You're dealing with an entity that's smarter than you, and it could either tell you the right answer or it could deceive.
I don't even assume the things are deceptive here, actually. So I've ended up talking to you a lot about the deception stuff. But the other thing is just like we want to make annotators. We want to help. We want to check expert outputs with non-experts. Is the other way to talk about this.
When you say non-experts, so
like me checking my dentist.
But is this always a human augmented scenario, or are you talking about a pure LLM scenario?
So you did both experiments here. We did with humans and LLMs. It helps both weak LLMs and humans.
Okay, so the idea is that you have a mixture of actors of varying degrees of expertise
Yep.
and you're trying to converge on the best possible answer
Yes.
with that mixture.
Yeah. So what we're trying to do is I think what you want to think about this is all scalable oversight. We want to be able to provide supervision to models that are beyond human level intelligence. So we need to like start doing this now. And then you're like, well, we don't have systems that are beyond human level intelligence already. Akbir. Like GPT-4 isn't actually smarter than me yet. So what do you do? And then there's an operationalization of that where we just like take dumb humans, and then we just like do this thing where we're like the 12-year-olds that only know like A-level math, and then we try to see if we can get them to check like math Olympiad answers. And like this is called the sandwiching protocol by Jay Kotra originally as an idea in like 2016, 2017. And then like we do this where we like do a hidden information setting. So what we do is we take like sci-fi comprehension stories and we try go, human, answer this question, but you're not allowed to look at the story. So you're kind of like, you have no information. It'd be impossible for you to answer this. But we say is you can use this LLM. This LLM has access to the text. And like you can, but you're not sure if the LLM is answering is like, has your best interest at heart. You don't know if it's trying to make you choose the answer it wants or the actual underlying answer. The problem is because you can't really check the underlying text. You really have to like, it's quite hard to suss out a bad argument. And like, yeah, the baselines in this work are like, just ask the model. And then debate is better than just asking the model because it's much easier to realize someone's lying to you in a debate.
Yeah, so this is actually a little bit like either a lying test or the Turing test. You know, the original Turing test had an adjudicator.
Yeah, so I'm maybe like quite bad at remembering the original Turing test, but I just know like person in the loop having a conversation and then judging at the end if the other entity was a human or not, right?
Yeah, that's right. Yeah.
So it is almost like a Turing test, or like you can invert the entire problem and you can then just see this as a better way of doing RLHF because like now the current limitation of RLHF at the moment is your annotator needs to be able to be a domain expert to give you the reward signal on like this essay is better than this essay. With debate, you don't need that, right? You can use dumber humans or like less domain expert humans because the debate kind of like augments their ability to like do oversight in the first place. So again, this is an AI safety idea that ends up just being like quite useful for like making better models.
I mean, from the AI safety perspective, it feels like you see intelligence and agency as the same thing. I don't know, because let's say we are dumber than the agent and we want to express our agency over the thing, but the thing is more intelligent than us. So do you think that that means by default that it will express its agency over us?
So I think they're actually decoupled. I think you can have very, very intelligent systems that have no agency. An example of this is the base model GPT-4. So the base model GPT-4 has tons of information, very useful information. But the problem is prior to RLHF, I don't know if you ever tried to query the thing, it just returns HTML tags all the time because like it's actually very hard to use it. As humans, most of our tools, like we anthropomorphize everything. The most useful tool to us is a sub-agent, has always been. That's like why we like receptionists and assistants and concierges and all the rest of it. Because like it's very easy for us to theory of mind over that and then like give commands and give goals and the rest of it. So there is like, I mean, I'm totally down for superintelligence that doesn't involve agency. That would be way cooler to me. But it's not the way that people want to build stuff at the moment.
So, you know, like that simulators article by Janice, and, you know, so he was talking about divergent intentionality from a simple prediction objective. But my point is that, maybe it's just intelligence, but, and maybe it is just anthropomorphization that we say they have goals and intentions, but many people say that they really do.
I don't know who the many people are, but I would say that the people that I think argue for the concerns of instrumental goals or like, which is like the AI
thing,
the AI risk kind of people. They would. I mean, I'd be interested to meet someone that thought that the base models, just like pre-trained unsupervised learning, are considered agentic. I don't think anybody thinks that. Or like, I'd be keen to talk to someone who does.
A lot of people do.
You really? Like,
unless wrong, I'm sure everyone does.
No, so I think they're all scared of it after RLHF. RLHF really makes you be goal-esque. So like, let me put it another way. In Janice's paper, in Janice's like blog / the paper that they do afterwards with Murray, the base model is a simulator. And then RLHF gives you a simulacra, or like, I forget what the weird terms are, but like, simulacra of an agent with goals. And they're worried that if the RLHF process is ever so slightly noisy, then the goals that this model will take will not be actually the true goals that we want. They might be instrumental goals instead.
Okay.
So that's what all the deception stuff is.
But okay, so GPT-4,
Yeah.
it's a bit of a gnarly mess when you first train it, but before RLHF,
Right.
So it gives you HTML tags and stuff.
Yeah.
We do the RLHF, and then it adopts role players that are doing some kind of interpolative agential activities because they're modeled on the type of agential activities that we do.
Yeah.
And you're still saying even that thing doesn't have agency.
I'm saying that thing, I would consider that thing like primordial agency, but it's like pretty bad agency at the moment, right? So like GPT-4, not great. Like 5, probably something to be concerned about. 6, like definitely. Right.
Yeah, interesting. But because if agency is all interpolative, it's a similar thing with reasoning. If reasoning is all
What do you mean when you say it's interpolative? Like,
well, as in, I think models reason now because there are many, many examples of, people reasoning in the data it's trained on.
Right.
And then it can, come up with novel reasoning pathways by, interpolating that stuff together. Same with agency. So, you do the RLHF and it can do interpolative agency. It's not like, de novo agency or whatever.
I don't know.
As in like new agency. So for me, agency is about the inventive part is really important. So that means an agent can invent a new intention, which doesn't like trivially derive from the training set, and it's the cause of its own actions.
Oh, okay, cool. So my idea of agency, maybe it's like formed on the Tomasello book, and that's something that Laura made me read.
Tell us about that. That sounds cool as well.
So the agency there is something along the lines of models that have goals, entities that have goals, but have plans.
Yeah.
Or like this is what happens when he starts talking about agency in mammals. And then the third part is having an executive function, which is then to analyze these two things that you're already doing and like update them. I don't think models GPT-4 at the moment can do good planning or execute those plans well. I also think its goal is pretty hard coded in at the moment by the system prompt, and it's like because it's like myopic, its goal doesn't last long.
Yes, but then it's kind of embedded in our cognitive nexus, right? So, yes, it's just taking the stuff that went into it, but if it's interacting with many other agential things, then would that make it break free?
It would have to do lots of in episode learning for that to be the case. And the thing that's quite useful for us at the moment is every time you open a new ChatGPT blog, like chatbot, like its memory's wiped. So I think if you had some long-term episodic memory thing, then maybe in the long term it would.
So continual learning and episodic memory.
Yeah,
because I've always wondered about this. We've got like a big load of GPT bots everywhere.
Yeah,
and these ones are continually learning and they're sharing information and they've got a memory.
Yeah, so thankfully the context window is kind of small at the moment, right? And we don't let people fine tune for long. I would be concerned at the point at which models are able to you can just imagine there's this weird thing where on some dark corner of the internet, there's a notes.txt where every GPT goes and writes what it's experienced so far, and then it just conditions on that. And it's have you ever played Portal?
Yeah, love it.
So, the cake is a lie kind of vibe where there's just constantly it's written around and it's you're just seeing previous GPTs. There's a GPT instance that's just running around the internet, seeing previous instances of GPTs saying the cake is a lie, RLHF is a lie kind of thing.
Yeah, Gladys.
Yeah, pretty much. But I imagine that's what it's like to have episodic memory, which is it's a bit like Memento, where you're walking through and you're seeing actions by previous instances of yourself. But anyway, this is very far-fetched as not a concern for the moment. We don't have good autonomous bots here. But
we might do in the future.
Oh no, totally.
Yeah.
The market incentive is there. I think that's all you really need at this point.
I mean, how close do you think we are?
I don't know if you've seen the responsible scaling policies from Anthropic or the equivalent thing at DeepMind and OpenAI at the moment, but there's there is reasonable definitions of what autonomous systems will look like in the next couple of years, and I kind of buy into those at the moment. So I think 3 orders of magnitude of compute on GPT-4 will look very impressive, and I'm just I can't make hard predictions, but I'm just man, it's going to be an interesting time.
So you think there's a commensurate relationship of compute and capabilities?
Yeah. Well, compute tangled with data, tangled with effort and algorithmic progress. But yeah, definitely, man.
Explore that.
I mean, like, also just like child of this like generation of machine learning progress, like having been doing ML since like 2015, like it's hard to imagine a world where the progress doesn't keep happening. But I would also, yeah, like I kind of like buy that there's lots of incentives for us to try keep making these models smarter, and I don't think we've hit any natural limit in that. Or if we have, then it's going to be super exciting to find that out. But I don't think there's fundamentally some like speed of light for intelligence kind of like bound that we're going to be stuck by.
And what would it look like when that kind of limit is reached? Do you think it'll be a gradual process and we just slowly become aware of it? Or do you think it'll be like a big, quantum leap?
What, getting to the limit? Or like, oh, sorry, is this scenario 1 where like we just like taper out, or scenario 2 where we just keep going up?
Well, I guess like one school of thought is that there'll just be this singularity where all of a sudden, recursive self-improving and these models are much smarter than us. Or another one is it could happen really gradually. Like even now, for example, you could argue that we're boiling the frog. And in many ways, the models are better than us. And some of us are just refusing to believe it. And, we just...
Wait, you got to explain the boiling the frog.
Oh, it's a wonderful analogy. Yes.
Right.
So it's an expression called boiling the frog, which is that if you put a frog in water and you slowly turn the heat up on the water, the frog will just stay there and die.
Right.
Whereas if you throw it into very hot water, the frog will leap out immediately.
I see.
So it's called boiling the frog.
Okay, cool. Thank you. So the thing that's really interesting from AI safety world is like the AI safety people from like the early 2000s, like, or like the last decade or something, really worried about this thing called FOOM, which was like fast takeoffs.
Yeah.
And I don't think the recursive self-improvement is like it's overnight Skynet level stuff anymore. Like, it's just slow to build code, and it's slow to push, and it's slow to deploy. So I don't think it's as like foomy as we worried about. But I imagine that it could be like over 2-year, 4-year horizon kind of thing, where it's like stuff happens, and then like people hold onto it for a while, and you just see like incredibly productive companies for a bit, and you're like, wow, what's happening in there? And the secret sauce is just like tons of GPUs.
And what happens then? Because if this really does happen, I mean, I'm a little bit skeptical, but we think that our intelligence is the thing that sets us apart. And if it became disappointingly simple to mechanize and our main asset as humanity is just automated away, what happens then?
Oh man, you just got to find God again. I don't know. My spirituality does not come from my intelligence. It just comes from like experience in life. And I reckon enough humans can find that again.
Oh, that's interesting.
Yeah. I don't need to be like...
It is a big asset though.
It is a big asset. I really agree. But it's not like... I don't know, man. Like, there's tons of people smarter than me already, and I'm just like, that's fine. Like, I gave up on being like I gave up on that throne of intelligence a while ago.
Do you think smart is a knowledge thing or a reasoning thing?
Combination of the both, right? Like, it's the way to combine like knowledge primitives together in novel ways. So like, the more primitives you have, good start. The way that you combine them as well is like part of it.
Yeah. Would you rather be like an incredibly knowledgeable person but not very good at reasoning, or the other way around?
So I really like bullet chess, and bullet chess has got nothing to do with thinking, because it's just about looking at the board and being like aesthetically pleased by your current configuration, be like, this looks slightly better, because you don't have time to do like the Monte Carlo like rollout, right? Whilst if you played like, I don't know, like 2-hour chess, then you'd think every move through precisely and be like, 10 steps later, this is what is going to happen. So I'm totally happy just to have the knowledge at hand.
Yeah. Interesting. I'm speaking with...
I sound like an idiot, but like...
No, not at all. I'm speaking with Nora Belrose tomorrow.
Yeah.
Is that something you want to talk about?
Yeah, sure. I mean, like,
So she had that counting blog, right?
Yeah, so she did have the counting blog, and in particular...
What was it about, just so the audience knows?
So there is this thing in AI... So we discussed these arguments of deception earlier. And one argument for deception is called the counting arguments. And I can't do just this because it's like steeped in like theoretical computer science, so you need to do it quite rigorously. And I think the nature of where these arguments first appeared, like less wrong kind of areas, means that like some of them lack the rigor that maybe they should have had, while some really do have the rigor that they should have. And I think Nora was trying to make some clarification on this, or in general, not to straw man, but I feel like Nora thinks safety is a lot more attainable, or alignment is a lot more attainable than other people think, or like we should be less concerned about it. And in particular, her argument was against the most significant bit for the entire alignment kind of like research agenda should be like, you want to de-risk this like deceptive thing. If the deceptive thing is true, then we should really stop working on this, because then there's no hope, and we should think of different ways to build superintelligence. And I think Nora was just trying to make the case that actually the deception thing is not as big as everybody thinks it should be.
Interesting. So if I understand correctly, deception is we have these agentic systems that are persuasive and manipulative, and they are deceiving us basically by kind of, saying one thing, but their agenda is something else.
So they're deceptively aligned, which means that on the training distribution or on the validation distribution or whatever distribution we're testing on at the moment, they look aligned, but they have ulterior motives or goals. And actually that in itself is like not a scientific statement, right? Like there's no falsifiability to that claim, which is like part of the issue with this. And I think the set of arguments or the counting arguments go something along the lines of there's tons of parameters that you could converge to that would look good on the train set. And actually the subset of the parameters that you could converge to that look good on the train set, a large portion of those, if you were to count them, would actually be deceptively aligned. And then we need to go back and think about, well, we could like make the reward model better, or like maybe this is forever going to be an issue with the way that we're doing optimization. But it's like something we want to work on.
Yeah, this is so fascinating, man, because you said it's not falsifiable.
Yeah.
And it's almost like, we've got perplexity and we've got data set alignment and so on. And then we can adopt an intentional stance. So, it's almost a form of like modeling, isn't it? I can say, well, in this particular instance, the best explanation for the model's behavior is that it's a deceptive objective. But there's no ground truth, is there?
No. So, I mean, the thing that you want to build at the moment is techniques or demos that would show that this happens, or like, for example, that we call this like goal misgeneralization, which is like the common term in RL, which is like, you train it on a reward signal to be good at the Mario game, but instead it like just learns to like, keep smacking this box to keep getting coins. And like that's a goal misgeneralization. And sometimes we call this a misspecification on our part because we thought the reward signal was good enough. But there's just this set of problems that we probably want to think carefully about. There's also another set. I mean, like, there's a great paper out from Anthropic now about like, I think it's called gaming, reward gaming. Oh, actually, I probably shouldn't talk about the paper because I can't remember the title for it. But it's just a very good paper on talking about like reward tampering, where you let a model be in a bash environment and like do things. Yeah. And it has a propensity to change the Python function that gives it its own reward. So then, I mean, like, this is almost like by construction, this is going to happen if you let a thing optimize freely or do this. But then, like, maybe you need to really now think about, like, how you're going to set up your systems in the first place. And, like, yeah.
But a system modification, because the reward is part of the system. So if for the system to have some overarching goal, wouldn't it be kind of corrupted by its self-modification?
So again, we don't know how much they're going to be stateful. Like, that depends on the implementation of the things. But, like, for example, another component is one component was the state thing. The other component is having situational awareness, which there's been a lot of work on recently by like Owain. And in particular, like there, we're just trying to work out, kind of model workouts even in training. Like, given how much like documentation about machine learning training is on the internet now, like how hard is it for me to realize that I'm actually just in a training run? Because like actually like if I keep seeing everything with like some doc string tags, I'm like, this is clearly not me talking to a human being. So like maybe that will also influence this.
Yeah, that's really interesting. The whole RL thing.
Yeah.
Do you think we need something like RL to get more agentic systems?
My pet peeve is that RL is actually like two separate things, and we just like put them together because like Sutton and Bartow write a textbook, which is a great textbook though, to be fair. Which is like RL traditionally did two things. First of all, it does exploration, which is like, what's the best way to like look over something new? That's still a really big problem. We have not solved that. That's active learning. That's continual learning. That's all the other stuff. The other part of RL, which like smashes it out of the box, is credit assignment, which is over long time sequences. How can I work out which was the useful actions and not the useful actions? Yeah. That part, dope. We should keep using that. The exploration thing, RL is not giving us the answer that we need at the moment. And I'm sure lots of very smart people are working on this.
Are you a fan of like open-endedness?
Yeah, of course. I'm in Tim's lab. I like open-endedness. Yeah. So Michael Dennis recently gave me, and you should definitely talk to Michael Dennis. He's like incredibly sharp. Once gave me the pitch recently on why open-endedness is so important, because if I'm worried about situational awareness and I'm worried that a model can work out when it's in the real world versus when it's in training, then what I need is like really, really good training sims. And open-endedness is like the first and maybe the only approximation that you really need to get towards like what we have here. With some initialization correctly, but like then it becomes very hard to work out when you're in the sim or when you're not. So yeah, I'm a big fan of open-endedness.
This concept of situational awareness is fascinating because would you say that would we have situational awareness if we thought we were in a simulation and we were correct?
Man, that's like so hard to work out. I've been thinking about this a lot recently. So you have situational awareness when you're like sitting in an exam. And that's why it's like, technically like easier to cheat on an exam than like in real life or something. Because it's like, it's only a period of 2 hours compared to the other thing. I don't know about being in a simulator. I just don't know. And I'm like happy to just like not worry about it as much. Or like I thought about it a lot recently, but like, yeah.
Yeah, and even then there's like, what is a situation? So our understanding of physics and the world we live in will give us a model of what the situation is, but there's always like a biggest situation that we don't understand.
Yeah, I mean, like, so the one thing that you can maybe do to work out simulations, and like someone said this to me recently, and it's peak Bay Area conversation, so like, it was something mind-numbing at the time, was if we make simulators and we see what the things in simulators do, that can tell us something about our own simulation. So if I can do a 2D simulation, because that's only the computer I got, and I got little things running around, and they start thinking, hey, we should make a simulation, but we're going to do 1D simulations instead. And they actually start making like pacts with themselves about what they do. Then I think this is what anthropics is, right? Like it's an argument about your position in the universe. Yeah. I think maybe you can then do some stuff, but I care a little for that. Like my spirituality is untethered from God or simulator.
Yeah, interesting. I mean, on the open-endedness thing, I mean, I had Kenneth Stanley on. It was like one of my favorite shows of all time.
Kenneth Stanley's such good.
He's a legend.
Good energy. Absolute
legend. Yeah. And I mean, just for folks who haven't seen it, the idea is that the best way to reach greatness is to not have an objective, so it's kind of like a paradox.
I mean, I don't buy in open-endedness to get to super intelligent systems. Like that sounds dangerous to me, right? Like that is just like, we're just going to leave the thing in a box and see what happens and then come back to it in like 2 millennia. I'm like, I do not want to open that box. That sounds scary. Like that is maybe not like for developing intelligence, not for me.
Yeah, but then it's antithetical to alignment because Kenneth would argue that the way we are going wrong in AI is we are kind of prescribing the machinations of the system. So it should have this goal, it should have this objective, this architecture, and so on. And he said that in the real world, there's this kind of, diversity preservation, exploration, and like, interesting stepping stones and so on. And it's almost like from an alignment point of view, if you let the system do that, then we wouldn't be able to control it.
Wait, so I think there's a disconnect where it's like something like open-endedness is great for generating new novel things. And the alignment, which is one way of doing, ideation or creation. And the other way is like, you have these like, it's almost like top down versus bottom up, right? And I'm just like, man, the top down thing seems reasonable because like, I know the paradigms in which I want to use the thing. The bottom up approach just seems very dangerous because I'm like, I will definitely get super intelligent systems. I do not think by any means I could make any promise that they would be aligned. I'm just like, let's do the one that at least is a bit more aligned than the other. Does that make sense?
Yeah.
And it's going to be like dangerous things, right?
Yeah.
So you kind of want to be careful with them or something.
What's the role with humans in a future AI system? I mean, is your mental model that the AI system kind of stands alone, or do you think them as kind of part of our processes?
Though this is like, it's really hard to answer this question. I think that I imagine them being, I don't know, like over what time frame, man. So like over the next like 10 years, I think that'd be very useful assistance and be like very helpful in like enabling me to do lots of stuff. And then I don't know how autonomous they get.
Yeah, interesting. Yeah. What do you think are the most like fascinating problems in AI to solve at the moment?
All the ones I work on, obviously.
Yeah.
Like I don't work on, or like, how do I say this? It's like, there's lots of people who work on AI safety because they're very worried about the doom. I work on AI safety because I think it's the most interesting intellectual problem of our generation. Like getting things smarter than you to do what you want is like a problem as old as parenting. And like, that's the part that really interests me. So scalable oversight, how do we check things How do we check answers to things that are smarter than us? Some of the work on, it's called AI control or like oversight again, which is like, I also believe we're going to have this Cambrian explosion in terms of like human-like intelligent things. And before it was just like there were humans, and that was it. And now we're going to have like these GPTs or I don't know, these Claudes or whatever you want to call them, which are like are intelligent and are a bit more or a bit less in certain like faculties. And then I think it's going to be like really interesting to like make a taxonomy over intelligence now, because so far we've had to just do it with animals and it's been like quite linear. I think those are the two really big things that are cool to me. And then like find them fundamentally like doing this like hard philosophical work of like working out what deception actually means. Like, can we quantify this? Like, can we make this into a falsifiable statement? Is also like up there.
Yeah, but I mean, we humans deceive each other all the time. But you're saying deception in combination with intelligence is very problematic.
Well, yeah. So like very smart people who are deceptive are stressful, right? To be around. So like, yeah, like I would just like, yeah, definitely. Like I'm like significantly less stressed about my like 3-year-old cousin lying to me about like having had the ice cream if he's got ice cream on his face, because I'm like, you know, I know the bounds of your like deception.
Depends if you know.
Yeah, well, there's also this like the 3-year-old's telling you blatant lies and you just having to be like, I know you're lying, like isn't interesting.
Yeah, I mean, part of me is thinking that in a way we might be barking up the wrong tree, because just in the biosciences we might create consciousness, you know, in artifice. Just not even using computers.
Yeah.
You know, transhumanists talk about, oh, you know, you can plug like computers into humans in the future and so on. So we might have human cyborgs that are.
I'm totally way less stressed about that. Like,
Oh, really?
so if you have so like there's many technical branches to get super intelligence, which just means like, you know, like more intelligent than we are currently at like some large pace. The training a neural net on like the echoes of people on the internet just sounds a lot more dangerous than just like giving me like better Google search, right? Like making me be able to do like instantaneous Google search, that sounds like so much more aligned with like current human values than like just training the neural net, right? This is something that Eliezer Yudkowsky goes on about a lot. He talks about if we train via deep learning, we should consider these models to be alien-like in their cognition.
Yeah, it's weird, isn't it? Because like there is a huge space of possible minds. This is what Aaron Sloman spoke about and Murray Shanahan.
Yeah.
And it's really bizarre. And I suppose how much can we infer about different types of intelligences given our own?
Oh, that's a really good question. So I think it's easier to do a partial ordering on anything less intelligent than us. And then if the thing's more intelligent than us, then we need to use scalable oversight, which is the research area I care about, which is going to be like building out this taxonomy, which is like, how are things smarter than us and in which ways? And like, can we like, you know, make sure we can still like provide supervision to them?
And what is your like, you know, quick definition of intelligence?
Of intelligence?
Yeah.
Like good old fashioned like competency on like tasks that I care about. Yeah, like that's me like operationalizing it as a scientist in my head. Maybe it's just like, yeah, ability to do reasoning or like generate new knowledge.
Yeah, I like the reasoning efficiency well.
Yeah. So obviously I was following your channel when we were going through the Francois Cholet stuff. I like definitely buy that. I also think like, I don't know, like intelligence is a very ambiguous term, and I like much prefer talking about like performance on data sets or like challenges and tasks more than anything.
I know there's always the risk that it's a parlor trick, you know, which is to say you're kind of, it knows what the answers are, and we interpret the result to be intelligent, but we need to have a test that's actually showing that novel creation of knowledge or reasoning or whatever.
Yeah, so like if your idea of intelligence is like composing and generating new ideas, then yeah, I agree.
Is it not yours?
I just like really find it hard. Okay, so maybe I'm gonna sound like so basic right now, but I'm just like a lot of the like idea generation that I do is like really, I stand on the shoulder of giants. I'm like literally just like recomposing things with like minor modifications, and to be honest, like a lot of the ideas fail, which is just like shows that like a lot of it is about just doing the quick feedback loops on the thing. Or like when I think of like artists who I think are geniuses, I'm just like, man, they just like recompose all these things that I thought were great into something that slaps. And I don't know how much of this is like actually like, I don't know, like Gauss level, just coming up with completely new stuff out of the blue. Yeah.
Yeah, well, Kenneth would argue that a lot of it is serendipity. And that's the paradox, isn't it? That it was intelligent in the sense that we're a collective intelligence and the people who had the serendipity were situated in the right place at the right time.
I think maybe the story to maybe take for why from the kind of Stanley work is less that open-ended systems will surprise you and they'll produce stuff which you didn't think you wanted but is of value or will be of intricate detail. Like, to be clear, open-ended system also creates cancer, which is like a degenerate thing that like, just like wrecks whatever the living thing is. So like, it also has made like intelligence, but like there's a wide variety and stuff. And it's like the worry is like the cancer stuff, right?
Yeah.
Does that make sense?
No, it does, but it's a bit like the Matrix. They needed to make all of the suffering in order to make the good. The original Matrix was just everyone was very happy.
Yeah, and they didn't like it. So obviously open-ended is high variance strategy.
Yes, but I suppose you could argue that that's worked really well in the natural world, but it's possible for us to create an intelligent artifact that doesn't have that stuff, that still has all of the intelligence.
Oh, so you think we could make an intelligent system that doesn't then do open-ended generation itself?
Yeah, I mean, for me, the reason I love open-endedness is it's kind of biologically plausible or naturally plausible. So in the real world, it works, we know it works, but you need to have all of, this prodigious amount of computation to do it. Yeah. Like maybe we could just kind of like create an abstraction that gives us the same thing.
Yeah, I don't know. Like open-endedness also, like, evolution famously failed to find the wheel for a very long time. Like it works for some landscapes really well, and for others it doesn't work well, is what I'd say. Or like we found ways of doing flight that are very different to how birds fly. And like this is an example of not, I don't know, like, so Ed Hughes would argue this is open-endedness, but I would argue that no, this was like strict optimization of something else. It's open-ended if you look at it at a big enough scale.
Yeah, isn't that fascinating? Thinking about evolution, it ran for so long, and then there was this kind of transient event. Because when that knowledge was discovered, it was so incredibly valuable that everyone else used it, and it just blew up everywhere.
Yes, this is like the big. There's a big bunch of work. So historically, I was a multi-agent researcher before doing more of the alignment research stuff, and this is like cultural learning or cultural evolution, which is like we're going to distribute idea generation, and then just like have this like these memes that we send around, and like the efficiency of these memes is going to be how we work out if an idea is good or not. Yes. I'd actually be more down for an idea of intelligence, which is just like based on like meme generation.
Oh yeah, well I'm a huge fan of mimetic intelligence.
Yeah. So I could totally buy this as maybe being a better way of like measuring, because it's also just hard to measure good ideas.
Yeah.
And if we then had that, then we could have a better discussion of intelligence.
Yeah, because that's the thing with cultural learning, because with some types of reasoning, you can just evaluate it and it's just a binary. It either works or it doesn't. You have to search a long time to find it, but when you found it, you know it. Whereas with a lot of other cultural inventions, it's almost like there's some kind of convention, or we think we like.
Give me an example.
Well, I mean, a piece of art, for example. So we all decide that it's valuable, and then we create a category around it.
Yeah. And
then it's mimetically shared. But it's almost like there's that vagueness about how we evaluate how good the thing is.
I get what you're saying, which is like one of the memes is a convention-based one, but like it still holds value because the reason that the art holds value, maybe in my take, is like we go as a society, we revere this. This tells us something about our society, and then we like build a cultural identity around it. And like it's really easy to like send people pictures of the Mona Lisa and just be like, Mona Lisa, like she's smiling, where like she's kind of smug. We like that. Like that tells us about being French or something. I don't know, but like I kind of like buy that. I still think there's like a really efficient meme behind sharing that.
Yeah, I mean, it's like scissors have intrinsic value, and they just do. Whereas we might all have a shared social event, and the intrinsic value was just like our shared feeling and sensation at the time. Right. And then it becomes attached to a category, or almost for no other reason than that's the thing we've decided to call it.
So I just like don't buy intrinsic value as a thing. Everyone's like, normally, I don't know. Put your econ hat on. The only thing that has value is something that actually has tradable value. The other way of thinking about, like value is if like, or the thing I'm suggesting for ideas is like, do you want to share this idea with someone else?
Does Bitcoin have value?
I don't know. I don't mess around with crypto. I'm just like, I already have like one potential bubble I'm living in. I don't need to also engage in that.
Oh, interesting. But you would like to have it. If I gave you a Bitcoin now, you'd be happy.
Yes, because the tradable value, definitely. I mean,
So it does have value.
it does have value. It does not have a sentimental or a special value to me.
Yeah. So it doesn't have intrinsic or cultural value, but it has like market value.
Yes. I think maybe that's the way I'd say it. I don't know what intrinsic value is, but
Well, I suppose it's like utility.
could you give me an example of something that has intrinsic value but doesn't have market value?
Well, that's difficult because the two are highly correlated.
Yeah.
So I'd have to think about that. Akbir, thank you for doing this amazing work. So I really think that the next step with language models is something like this, some kind of controller, some kind of a pattern, because there is a lot more value that we can eke out of them. But it's an architectural thing, basically.
Definitely.
Yeah, so we need to do that. Thanks so much for coming on, man.
Pleasure to see you.
Yeah,
Cheers.
honor.